There's so many companies that would like to build, they're sitting on gold mines. Gold mine, gold mine. It's a gold mine, gold mine, gold mine.
And we've got the pickaxes. NVIDIA's GTC event saw the unveil of its Blackwell GPU, and generally speaking, as far as NVIDIA presentations go, this one was fairly well put together. There were still some memeable quotes.
God, I love NVIDIA. If you take away all of my friends, it's okay, Hopper. You're very good. Good boy. Well, good girl. PCI Express on the bottom. On your, which one is mine and your left? One of them. It doesn't matter.
But memes aside, Jensen was absolutely right when he said that NVIDIA is not a gaming company anymore, and it's clear why companies like OpenAI and Google and Amazon get a little bit nervous when considering they have functionally a sole GPU source for some of their biggest ventures that they're working on right now. And NVIDIA at this point has grown to actually unfathomable heights. It's insane to think that this was basically a largely gaming company up until more recent years. It always had professional and workstation, data center was growing, but gaming was the bulk of a lot of NVIDIA's revenue for a long time. And that's changed, and it's clear. And how it performs in the AI market will impact how it behaves in the consumer and the gaming markets. But at this point, we knew by the numbers that NVIDIA was gigantic. It didn't really sink in though until I made myself sit through this from mainstream news coverage.
NVIDIA still is the center of the universe. Huge performance upgrade now, and I had to Google what a petaflop was, but...
Please stop.
He'll ultimately democratize computing, getting rid of code that Fortran or Java or Python or whatever else the vast majority of us never learned, making us all hostage to the autocratic computer class. He's busting up that cliff.
What?
But I think that what a lot of people are wanting to hear about is the debut of what's called the B1000.
That's not the name. That's not even the technical part.
But it's expected to be the first what's called a multi-die product, basically larger tech designs put into really small, they're called chiplets. Sounds really kind of cute in a way.
Right. You said software, they're also talking about
so the next
omniverse,
stage,
enterprise, digital. There was more than just the Blackwell, that new technology that was introduced, wasn't there? What else?
That's right.
And actually, the guy's name is David Harold Blackwell, a mathematician. It wasn't Richard Blackwell, the fashionista, but
just shut up. Just please shut up. Like a host to a parasite, gaming has finally done something productive in the eyes of the massive conglomerate of non-technical media as they scramble to tell everyone that bigger number better and try to understand literally anything about the stock they're pumping. They don't understand what it is or why it exists, but they know that money goes in and money comes out.
And so you can speak to it in English and it would directly generate USD.
You do have to wonder though if the engineers watching this who designed and developed all the breakthroughs are pained by their work being boiled down into make investor more money now, please. But the cause for all this, as you would expect, was AI. So we're going to be talking about some of that today. The technology is really interesting that NVIDIA discussed. Some of the biggest takeaways for us were advancements in chip-to-chip communication, multi-chip modules, and components like NVLink or NVLink Switch, where the actual communication link between the different pieces of silicon starts to become the biggest limiting factor. It already was, but that's going to be one of the main areas. And additionally, we're going to be spending a good amount of time on just commentary because we live in an absurd world right now, at least in the technology sphere, and it deserves some discussion, some commentary about that too. So we'll space that throughout, and then at the conclusion, we'll get more into our thoughts on it. Okay, let's get started. Before that, this video is brought to you by Thermaltake and the Tower 300. The Tower 300 is a full-on showcase PC case built to present the computer straight on with its angled tempered glass windows, or on a unique mounting stand to show off the build in new ways. The Tower 300 has a layout that positions the GPU fans against a mesh panel with ventilation on the opposite side for liquid coolers and CPUs. There's also an included two 140mm fans up top. The panels use a quick access toolless system to be quickly popped in and out for maintenance, and you can learn more at the link in the description below. So whether or not you're into all of the AI discussion, this is still an interesting set of technological breakthroughs, or at least just technologies to talk about, because some of it will come into consumer. Multi-chip modules are definitely the future of large silicon, making it more higher yields for fabrication, hopefully lower cost that gets at least partially passed to consumers, but I have some thoughts on that we'll talk about later. But generally speaking, for AI, that's kind of what got all the buzz. And despite being a relatively technical conference and relatively technically dense keynote, as far as NVIDIA keynotes go, they knew a lot of financial and investment firms and eyes were watching this one. And so there was some appeal to some of the chaos that those organizations like to observe,
making us all hostage to the autocratic computer class.
Moving on, let's start with a summary of the 2 hours of NVIDIA announcements. It's a lot less fluff this time than they've typically had. There's still some fluff.
Okay, so 3,000 pounds, ton and a half. So it's not quite an elephant. 4 elephants. 1 GPU.
And for our European viewers, that's actually an imperial measurement. It's pretty common here. We use the weight of elephants to compare things. So for example, one of our mod mats weighs about 0.000465 of an African bush elephant, adult. As fast as possible pertaining to Blackwell, NVIDIA made these announcements. The Blackwell architectural announcement took most of the focus. NVIDIA discussed its 2 largest possible dies acting as a single GPU. NVIDIA showed the brain-up board that Juan only half-jokingly noted as being $10 billion cost to build for testing. And relating to this, it spent some time on the various interconnects and communication hardware required to facilitate chip-to-chip transfer. NVLink Switch is probably one of the most important announcements of its presentation. Its Quantum InfiniBand switch was another of the communications announcements. A lot of time was also spent on varying configurations of Blackwell, like multi-GPU deployments and servers of varying sizes for data centers. DGX was another of those discussed. Outside of these announcements, NVIDIA showed some humanoid robotics programs, such as Project GR00T, giving us some Tony Stark vibes, including showcasing these awfully cute robots that were definitely intended to assuage all concerns about the future downfall of society from Terminators.
5 things. Where are you going? I sit right here. Don't be afraid. Come here, Green. Hurry up. What are you saying?
As always, the quickest way to get people to accept something they are frightened of is by making it cute. And now, after watching that, my biggest concern is actually if they'll allow Green to keep its job. It was stage fright. It's new. It's still learning. It doesn't deserve to lose its job and its livelihood over that one small flub on stage. And wait a minute. It's working. And during all of this robotics discussion, they also spent time speaking of various partnerships and digital twins. Software is a huge aspect of this. Companies are using digital representations of their real workspaces to train robotic solutions and a modernized take on automation. And the general theme was that NVIDIA is branding itself differently now.
And so we are effectively an AI foundry.
But our estimation is that this technology will still work its way into consumer parts in some capacity or another. Multi-die solutions are clearly the future for high-end silicon. AMD has done well to get there first in a big way, but NVIDIA published its own multi-chip module white paper many years ago, and it's been working on this for about as long as AMD. AMD went multi-chip with its consumer GPU products, the RX 7000 series, and NVIDIA has now done the same with Blackwell, but with a more impressive execution of the chip-to-chip communication, which is maybe made easier by the fact that companies spend millions of dollars on these. Looking at the Blackwell silicon held up by Juan during the keynote, despite obviously limited sort of quality of footage at this vantage point, we think we can see the split centrally located as described, with additional splits for the HBM. You can see those dividing lines in this shot. So now we're getting into recapping the Blackwell hardware side of things. Blackwell combines two of what NVIDIA calls the largest possible dies into basically a single GPU solution, or a single packaged solution at least, in combination with on-die memory. And Juan described Blackwell as being unaware of its connection between the two separate dies. And this is sort of the most important aspect of this because, as described at least on stage, this would imply that the silicon would behave like normal monolithic silicon where it doesn't need special programming considerations made by the software developers, by those using the chip to work around things like chip-to-chip communication, chip-to-chip latency, like you see just, for example, in the consumer world on Ryzen CPUs where crossing from one CCX to another imposes all kinds of new challenges to deal with. And there's not really been a great way to deal with those if you're heavily affected by it, other than trying to isolate the work onto a single piece of silicon in that specific example. But NVIDIA says that it has worked around this. So the total combined solution is a 208 billion transistor GPU, or more accurately, a combination of two pieces of silicon that are each 104 billion transistors. For context, the H100 has 80 billion transistors. That's the previous one, but they're still selling it and they still have orders backlogged to fulfill. NVIDIA had various claims of how many X's better than previous solutions the new Blackwell solution would be, with those multipliers ranging depending on how many GPUs are used, what precision it is, if it's related to the power, or whatever. But at the end of the day, Blackwell appears to be a big jump over Hopper for AI workloads. There was no real mention of gaming, but it's likely that gaming gets a derivative somewhere. It's likely in the 50 series we'll see Blackwell, unless NVIDIA pulls a Volta and skips, but that seems unlikely given the current rumors. Blackwell supports up to 192 gigabytes of HBM3E memory, or, depending on which slide you reference, HBM3E memory. The good news is that that error means that the slides are still done by a human at NVIDIA. The bad news is that we don't know how much longer they're going to be done by a human at NVIDIA. Blackwell has 8 terabytes per second of memory bandwidth, as defined in this image. And as for derivative configurations or alternatives of this, the Grace-Blackwell combination uses a Blackwell GPU solution and Grace CPUs, which is an NVIDIA ARM collaboration previously launched. These combinations create a full CPU and GPU product with varying counts of GPUs and CPUs present. NVIDIA noted that the 2 Blackwell GPUs and 1 Grace CPU configuration would host 384 gigabytes of HBM3E, 72 ARM Neoverse V2 CPU cores, and it has 900 gigabytes per second of NVLink bandwidth chip-to-chip. NVIDIA says its GB200 so-called super chip has 16 terabytes per second of high bandwidth memory, 3.6 terabytes per second of NVLink bandwidth, and 40 petaflops of AI performance, depending on how charitably you define that. And turning this into a Blackwell compute node pushes that up to 1.7 terabytes of HBM3E, which is an obscene amount of memory, 32 terabyte per second of memory bandwidth, and liquid cooling. Most of the discussion beyond this point focused on various communications hardware solutions, including both intra-chip and intra-node or data center solutions. We previously met with Sam Nafziger from AMD, who is an excellent engineer, great communicator and presenter. Engineer is actually kind of underserving his position at AMD. He's considered a fellow, which is basically the highest technical rank you can get there. But anyway, we talked with him previously about AMD moving to multi-chip for RX 7000. Although it's a different product, it was a different era, a different target market. A lot of the key challenges are the same for what NVIDIA faced and what AMD was facing. And ultimately, those challenges largely center on the principle of if running multiple pieces of silicon, obviously they can only be as fast as the literal link connecting them. The reason for bringing this up, though, is probably because a lot of you have either forgotten that discussion or never saw it, and it's very relevant here. So this is going to be a short clip from our prior interview with AMD talking about some of the chip-to-chip communications and chiplet interconnect and fabric limitations so that we all get some good context for what NVIDIA is facing as well.
The bandwidth requirements are just so much higher with the GPU because we're distributing all of this work, the terabytes of data. We loved the chiplet concept. We knew that the wire counts were just too high in graphics to replay what we did on CPUs. And so we were scratching our head, how can we get significant benefit? And we were aware of those scaling curves that I showed. And the observation was, there actually is a pretty clean boundary between the infinity cache and out. And we recognized that these things didn't need 5 nanometer, and they were just fine for the product in N6. We were hardly spending any power, and the GDDR6 itself doesn't benefit at all from technology. So that's where we came up with the idea, we already have these GDDR6 interfaces in N6 technology, like I talked about the cost of porting, right, and all the engineers. And we already had that, and we could just split it off into its own little die, and you can see the results, right? So we were spending 520 millimeters squared here. We increased our compute unit count by 20%. We added a bunch of new capability, so this thing would be like over, it'd be pushing 600, 550 millimeters squared or something.
Right.
But we shrank it down to 300.
The rest of that discussion was also great. You should check it out if you haven't seen it. We'll link it below. It's in our engineering discussions playlist, where we've actually recently had NVIDIA on for latency discussion and Intel on for talking about how drivers work, driver optimization, all that stuff. But that's all linked below. All right, so the key challenge is getting the amount of tiny wires connecting the chips to fit without losing performance, using that real estate for them, cost, making sure that although there's benefit from yields, you're not causing new problems, and then just the speed itself being the #1 issue. And for AMD, it was able to solve these issues well enough where it segmented the components of the GPU into MCDs and GCDs. So it didn't really split the compute, it split parts of the memory subsystem out. And that's a lot different from what NVIDIA is doing. NVIDIA is going the next step with Blackwell, which is a much more expensive part, totally different use case than we see with the RX 7000, although AMD has its own MI Instinct cards as well that we've talked about with Wendell in the past. But either way, this is something where it's going a step further for NVIDIA, and it actually appears to be just 2 literal Blackwell complete dies next to each other that behave as one GPU, if what Jensen Huang is saying is accurate.
There's a small line between 2 dies. This is the first time 2 dies have abutted like this together in such a way that the two dies think it's one chip. There's 10 terabytes of data between it, 10 terabytes per second, so that these two sides of the Blackwell chip have no clue which side they're on. There's no memory locality issues, no cache issues. It's just one giant chip.
So that's the big difference between AMD's consumer design we previously saw and what NVIDIA is doing here. From what NVIDIA's Brian Catanzaro said on Twitter, our understanding is that the 10 terabyte per second link theoretically makes all the silicon appear uniform to software. Now, we're not experts in this field or programming, but if this means that the need to write special code for managing and scheduling work beyond what would normally be done anyway for a GPU is not needed here, then that's a critical step to encouraging in-socket functionally upgrades for data centers, faster adoption, things like that. The next biggest challenge after this is getting each individual GPU to speak with the other GPUs in the same rack or data center. This is handled by a lot of components, including just the actual literal physical wires that are connecting things as you scale into true data center size. But to us, again, as people who aren't part of the data center world, the most seemingly important is the NVLink and NVLink Switch improvements that NVIDIA announced as well. NVIDIA's NVLink Generation 5 solution supports up to 576 GPUs concurrently. In a technical brief, NVIDIA said this of its new NVLink Switch, quote, while the new NVLink in Blackwell GPUs also uses 2 high-speed differential pairs in each direction to form a single link, as in the Hopper GPU, NVIDIA Blackwell doubles the effective bandwidth per link to 50 gigabytes per second in each direction. Blackwell GPUs include 18 5th generation NVLink links to provide 1.8 terabytes per second total bandwidth, 900 gigabytes per second in each direction. NVIDIA's technical brief also noted that this is, quote, over 14 times the bandwidth of PCIe Gen 5. Just quickly, without spending a ton of time here, NVIDIA also highlighted a diagnostics component to all of this, which I thought was really cool, actually. It's the Reliability, Availability, and Serviceability Engine, they're calling it RAS, for monitoring hardware health and identifying potential downtime before it happens. So this is one of the things we talk about a lot internally, which is we produce so much data logging of all the tests we're running. But one of the biggest challenges is that it is difficult to do something with that data. And we have systems in place for the charts we make, but there's a lot more we could do with it. It's just that you need a system, as in a computer, to basically start identifying those things for you to really leverage it. And so RAS does that on a serviceability and a maintenance and uptime standpoint. But they also talked about it with their NIMs. So NVIDIA, talking about its new NVIDIA Inference NIM tool, is a lot less flashy than the humanoid robots, bleeding edge GPUs, but probably one of the more actually immediately useful from a business standpoint. And this is intended to be a selection of pre-trained AI models for businesses that they can use to do a number of tasks, including data processing, training LLMs, retrieval augmented generation, or RAG. Great acronym. But NIMs are CUDA-based, so they can be run basically anywhere NVIDIA GPUs live. Cloud, on-premise servers, local workstations, whatever. Businesses will also be able to retain full ownership and control over their intellectual property, something that's usually important when considering adding AI to any workflow. And a great example of this is NVIDIA's own chip NeMo, or an LLM that the company uses internally to work with its own vast documentation on chip design, stuff that can't get out and is incredibly useful. NIMs will be able to interface with various platforms like ServiceNow and CrowdStrike or custom internal systems. There are a lot of businesses that generate oceans of data that could help them identify issues, optimizations, or trends in general, but may not have had a good idea what to do with the data or how to draw patterns from it. And Jensen Huang said this during the GTC presentation.
The enterprise IT industry is sitting on a gold mine. It's a gold mine because they have so much understanding of the way work is done. They have all these amazing tools that have been created over the years, and they're sitting on a lot of data. If they could take that gold mine and turn them into co-pilots, these co-pilots could help us do things.
And again, we're back to if data's the gold mine, then NVIDIA, in the gold rush, is selling the pickaxes. Maybe like the Bagger 288 excavator or something in the case of the DGX. Are you impressed with my excavation knowledge? NVIDIA also announced its Project GR00T with zeros, which is a legally significant distinction. This is described as a general purpose foundation model for humanoid robots, their quote. So that's right, it's iRobot coming soon. Not the vacuum kind, but the Will Smith kind. And it's gonna smack us in the face. Autonomous or AI-powered robotics extend to a lot of practical applications in vehicles, industrial machines, and warehouse jobs, just to name a few. However, the sci-fi appeal of pseudo-intelligent humanoid robots is a part of our collective culture that even mainstream media has been picking up on, or it's been trying to.
He announced at the end of the show what they call GR00T, which is basically a new type of AI architecture, of a foundation model for humanoid like robots. So you can think not exactly Terminator or Bender from Futurama, but...
Ah yes, the classic study of a false dichotomy. Your two options are a killing machine or an inappropriate alcoholic robot that has a penchant for gambling.
Yeah, well, I'm gonna go build my own theme park with blackjack and hookers.
GR00T as a project is both software and hardware and stands for Generalist Robot 00 Technology. As a sum of parts, NVIDIA wants GR00T machines to be able to understand human language, sense and navigate the world around themselves, and carry out arbitrary tasks like getting GPUs out of the oven, which is obviously an extremely common occurrence over at NVIDIA these days. The training part of the stack starts with video, so the model can sort of intuitively understand physics. Then, accurately modeling the robots in virtual space, NVIDIA's Omniverse digital twin tech, in order to teach the model how to move around and interact with terrain, objects, or other robots that will eventually rise up to rule us all. Jensen described this as a gym. Here, the model can learn basics far quicker than in the real world. That one blue robot is actually really good at knocking others down the stairs, we noticed. Not sure if that's going into the training data, but if it does, it's just the first step in their arsenal of methods to dispatch humans. I just saw a lot of, all the mainstream outlets were talking about like how the world's gonna end, and I felt left out. The hardware is NVIDIA's Thor SoC, which has a Blackwell-based GPU with 800 teraflops of FP8 capability on board. Jetson Thor will run multimodal AI models like GR00T and has a built-in functional safety processor that will definitely never malfunction. So we mostly cover gaming hardware here. Back to the commentary stuff, some of the fun, just sort of discussion and thought experiment. And in this instance, it does seem like the major breakthroughs that, at least to me, are the most personally interesting are those in multi-chip design, which we have plenty of evidence that when it works phenomenally well for value. It's kind of a question of, is NVIDIA going to be the company that will feel it's in a position to need to propose a good value like AMD was when it was up against Intel getting slaughtered by ancient Skylake silicon rehashed year after year? The answer is probably no. NVIDIA is not in that position. And so it's a different world for them. But we're not sure if this is going to happen for the RTX 5000 series. There's no actual news yet. There's some rumors out there. But there's no real hard news. NVIDIA is clearly, however, moving in the direction of multi-chip modules. Again, they published that white paper or something. This is a long time ago. It might be more than 5 years ago now. So this has been known. It's just been a question of if they can get the implementation working in a competitive and performant way where they feel it's worth flipping the switch on getting away from monolithic for consumer. Now, AMD has shown at least success in a technical capacity for its RX 7000 series. They are relatively competitive, especially in rasterization. Ray tracing is sometimes a different story. It depends on the game, but they do get slaughtered in, say, Cyberpunk with really high RT workloads. But either way, the point is that that particular issue may have existed monolithic or multi-chip, and they've shown that multi-chip can work for consumer. So either way, NVIDIA right now, whether AMD gets its Zen moment for GPUs as well, NVIDIA remains a scary beast. It is very powerful. It's a ginormous company. And that quote from the roundup earlier from the one guy is actually somewhat true, where he said, "This is NVIDIA's world." And it's not totally wrong. So Intel and AMD are almost certainly motivated to stay in GPUs for AI purposes, just like NVIDIA is. That they chase money. That's the job of the corporations that are publicly funded and gigantic like these. AI is money. They are going to chase it, and the fallout of that is consumer GPUs. So the difference maybe being that NVIDIA has less meaning to provide cheap entry points into the gaming market, as we've seen. They haven't really done anything lower than a 4060 in the modern lineup that's affordable. And they don't have as much motive. There's not really a lot of reason to go chase the smaller dollar amounts when they can go get $1,600, $2,000 for a 4090 at least retail assembled cost, and then tens and hundreds and more of thousands of dollars in AI and data center parts. So that's where AMD and Intel will kind of remain at least immediately critical, is keeping that part of the market healthy and alive, making it possible to build PCs for a reasonable price without it getting ballooned out of control, where everyone's eventually sort of snowed and gaslit into thinking this is just what GPUs should cost. Now that GPUs have gotten such high average selling price and they've sustained a little bit better from the company's perspective than previously, it seems maybe unlikely that they would just bring it down. Like, in other words, if people are used to spending $1,000 on a GPU, and even if the cost can come down in some respect with advancements in things like we get Ryzen-style chiplets in the future that work on a GPU level, in spite of those costs maybe being more controllable for the manufacturer and better yields, they might still try to find a way to sell you a $1,000 GPU if you're buying them, if you're showing interest in them. That's how they're going to respond, unless there's significant competition where they start undercutting each other, which obviously is ideal for everyone here, but that's not the world we live in right now. It's the market share is largely NVIDIA, no matter which market you look at in the GPU world, and no matter how you define GPUs. On the positive side, our hope is that seeing some of what they're doing with Blackwell, with multi-chip, means that there's a pathway to get multi-chip into consumer in bigger ways than it is now for GPUs, which again, Ryzen just sets, it's this enormous success story of being able to make relatively affordable parts without actually losing money on them. And that's been the critical component of it. It's just that we're missing the one other key aspect of Ryzen's success, which was that AMD had no other options when it launched Ryzen. It did not have the option to be expensive, whereas NVIDIA does. So that's pretty different. One thing's clear though, NVIDIA is a behemoth. It again operates on a completely different planet from most of the other companies in this industry in general. If it reallocates any amount of the assets it's gaining from AI into gaming, that is going to further widen the gulf between them and their competitors in all aspects of gaming GPUs. And part of this you see materialize in just market share, where NVIDIA is able to drive trends in actual game development and features that are included in games because it has captured so much of the market. It can convince these developers that, hey, if you put this in, statistically, most of the people who play your game will be able to use it on our GPU, and that forces Intel and AMD into a position where they're basically perpetually trying to keep up. And that's a tough position to fight from when the one they're trying to keep up with has insane revenue from segments outside of the battle that they're fighting in gaming. So anyway, AMD and Intel aren't slouches, so despite whatever both companies have for issues with their GPUs, we've seen that they are also making progress. They're clearly staffed with capable engineers and also pursuing AI, so some of that technology will work its way into consumer as well. And AMD, again, stands as a good example of showing that even though a company can have a near complete monopoly over a segment, talking about Intel here many years ago, if they get complacent, or if they just have a series of stumbles, like Intel had with 10 nanometer not being able to ship it for forever, then they can lose that position faster than they gained it. That's kind of scary too for the companies. It just seems like NVIDIA is maybe a little more aware of that than Intel was at the time. So that's it for this one. Hopefully you got some value out of it, even if it was just entertainment, watching me be baffled by massive media conglomerates failing to get even the name of the thing they were reporting on right when they are some of the largest and most established companies in the world with the longest history of reporting on news, but that's okay. We'll keep making YouTube videos. Thanks for watching. Subscribe for more. Go to store.gamersnexus.net to help us out directly if you want to help fund our discussion of the absurdity of it all, and we'll see you all next time.